In our daily lives, we go about things in a very particular way, most usually because we feel that's the best way of doing those particular things. But sometimes it's useful to stop, take pause, and see how other people tackle those same challenges. And maybe, just maybe, they're doing them in a better, more efficient way. So in today's video, we're going to take that idea of contrasting and comparing, and we're going to build the same API 3 times using 3 separate frameworks. Well, hello, wherever you are, whenever you are, where am I? Melbourne, Australia as usual. And when is it? It's September 2022. So great to be back here on YouTube and great to have all you lovely people here with me as well. So what are we doing exactly in today's video? Well, as I alluded to in the intro, we're going to build the same API, but we're going to build it 3 separate times using 3 separate frameworks. So we'll begin our journey by looking at Ruby on Rails, which is a very popular web development framework based around, no surprises, the Ruby programming language. We'll then move on, look at Node.js. We'll build an API in Node.js using the JavaScript programming language. And then finally, and this will come as no surprise to regular viewers of my channel, we'll build a .NET API written in C#. So why did I make this video? Simply to have a bit of fun, really, and contrast and compare frameworks that I don't usually work with a framework that I'm more familiar with, in this case .NET, and look and see what they do in the same way, similar way, or what they do completely differently. I don't know about you, but I find that really interesting. And perhaps if you're new to some or all of these frameworks, the video will give you some insight and additional information in which framework you maybe want to do more work with and progress down that particular path. This is very much an introductory, beginner level video, so just bear that in mind. Now, because we're working with 3 frameworks, there's a lot of context switching. There's lots of different command line prompts that we'll use to generate each of those 3 APIs. And so with that in mind, I have produced a free cheat sheet that you can download, and it has all the commands that will be running across all 3 builds. And there's also quite a nice feature matrix for all 3 frameworks as well. That is completely free to download. All you need to do is go over to lesjackson.net, register for an account, and you can download that companion cheat sheet. I've also done some bonus video content over there. Again, it's completely free, where I stress test or performance test our 3 APIs using a framework called K6. It's a very popular performance testing framework. That is just a bit of fun, to be honest with you, and the point of that video is just to introduce you to K6, which is really, really excellent. Really highly recommend you take a look at that, and that's free as well. And when you register for an account, you'll also get access to other free training on lesjackson.net. Anyway, I think we better get started with the video. 2 more things to say. If you like the video, give it a like, and if you haven't done so already, maybe think about subscribing, ding the little bell, and you'll be notified when I release new content. But that's it for this introduction. I think we better get started with today's video. So yes, hello and welcome to episode 5 of season 5, and today we're going to be building a .NET, Ruby on Rails and Node.js API. So yeah, I've already mentioned what we're building, but let's look a little bit deeper. So what we're going to actually do is build an API 3 times, but we're going to build a simple REST-based API. And as I've already said, we'll be using the 3 frameworks that you can see there, .NET, Node.js and Ruby. Now it'll be the same API from a functional perspective. It's going to deliver exactly the same functionality in all 3 cases. It's just going to be written in a different language using a different framework. And the 2 endpoints that we're going to implement in each of the APIs is just quite simple. We're going to have one endpoint that will allow us to read data, get all our items, and one endpoint that will allow us to create some items. So we're not doing the delete and update operations just for brevity, just to keep it quick. And the use case doesn't really matter that much, but if you want to kind of contextualize the API, what it's supposed to be doing, think of a very simple to-do application where you have a list of things you need to do, and you want to manage your life in that way with a to-do list. And it's really an API that would drive or provide that type of functionality to a front-end application. But that's not really the main focus of today's video. If you want to just jump to a particular section of the video, say you want to just jump to the Node.js build, you can do that by going to the description below and clicking on the relevant timecode, and it will take you straight to whatever build you're interested in, or whatever part of the video you're interested in. The code, as usual, is on GitHub, so the link to the repository is also in the description. And just for this video, I've also produced a free downloadable cheat sheet that basically compares the three, bit of a tongue twister, the three frameworks that we're working with. And I'll just give you a quick look at what that looks like. And again, this is free, you can just download it. And so yeah, it goes through and compares the three frameworks. It compares their feature sets, it compares the version of the framework we're using. And if I scroll a bit down here, you can see it goes through all the command prompts that we'll be using to create the app, to manage packages, to perform migrations, all that kind of stuff. So free download, check it out. Link is in the description below, as I said there. And then just finally, if you're totally new though, so this video really is aimed at beginners, to be honest with you. If you are totally new to development or writing APIs, I'd really recommend you stick around for this intro section and the theory sections, because I think there's some useful information in there. Just to kind of preface what this video actually is and what I intended this video to be and who it's sort of intended for, it's a beginner's guide to all three frameworks. So if you're an absolute expert in .NET APIs, you're going to find the .NET section somewhat light, likewise for the other frameworks. But if you're new to some or all of the frameworks, then this video will hopefully still be useful for you. But again, it's aimed at the kind of beginner level. Main reason I produced it is to allow for a side-by-side comparison of the frameworks and the features that they provide, and just to allow you to see how easy or how difficult it is to set these things up, and give you some kind of baseline or benchmark to allow you to make a decision on which one you might want to use. So again, typical use case would be maybe you're a student and you're tasked with writing an API, or maybe you're new to development and you're kind of investigating what framework you might want to use to proceed down your path with. And this video hopefully will give you some extra information to help you make that decision, make an informed decision. As I said there, will provide you some decisioning on which framework to use. So that was really why I produced this video, also because it's a lot of fun playing around with other frameworks. As you know, this is a .NET channel predominantly. I work exclusively, almost exclusively with .NET and C#, but it's still nice for someone like myself to see what other frameworks can do and how they compare. And it actually raises some really interesting insights when you do that, and hopefully you get the same insights from this video as well. What this video is not, it is not a question of going, this framework is better than that framework, and getting into all that kind of argument. I don't go there simply because I feel this is kind of a bit of a somewhat nonsense question when it's just applied generically. I don't think you can really answer which framework is better. I think you probably can answer this question if you've got some specific use cases, or you're applying your own personal preference. You might think one framework is better than another, and that's fine. But just generally, I don't think you can ever say one framework is just generally better than another. It might excel at certain things, and I'm happy to drill into that at some point in some other video, but this video is just an introductory comparing them, and we're not going to have a conclusion at the end stating one is better than the other. So that's not what this video is. We're not going to deep dive into any of the frameworks. It's kind of, yeah, fairly lightweight. We're just going to take the quickest, simplest approach, or what I feel is the quickest, simplest approach to getting three APIs up and running. And finally, I'm not providing an opinionated view on what production quality APIs should look like. So these three APIs are very much introductory APIs. There's a lot of stuff that is not included in this video just because I want to keep it as quick as possible. And so with that in mind, the approach I've taken is this path of least resistance, taking the quickest approach to getting three APIs up and running. All right, so let's move on to the ingredients that you'll need if you want to follow along. Now this first point, I would never usually suggest what operating system you develop on. That's a choice entirely for you, and in fact it still is a choice for you. The three frameworks that we're working with today, .NET, Node and Ruby on Rails, they can run on Windows, Linux and Mac OS. They are cross-platform, so you still can choose any of those. In this instance though, I would really strongly recommend that you use a Unix, Linux-based operating system. So if you're running Linux or Mac OS, you're covered. You can kind of somewhat ignore this next bit. If you're a Windows user, like I am, I'm running Windows, I would strongly suggest you use WSL2, Windows Subsystem for Linux. It's just an install. I'll put instructions below on how to install it. You install that, and then you install a version of Linux that you want to run. I'm using Ubuntu Linux. And what that means is it's actually very, very cool. You end up with your Windows machine, but you can then spin up or have Linux-based development environment as well. It's very cool. And we're going to be using that. I'm going to be using that in today's video, and it just sits side by side with Windows. It's a really good thing to install anyway. If you are going to be using Docker on Windows, generally speaking, for the most part, the recommendation now is that you install WSL2 and you run Docker on top of WSL2 as well. So it's not some crazy thing that you're never going to use. If you're a developer, you're probably going to use it anyway, even if you don't really know that you're using it. In terms of this video, it's my suggestion because certainly for Ruby, the Ruby language, and then of course Ruby on Rails on top of that, you can run it on Windows, you can run it natively on Windows, but I don't know a single Ruby on Rails developer that does that. And I know a lot of Ruby on Rails developers, and not a single one ever runs Ruby natively on Windows. They'll either use a Mac, Linux, or if they're a Windows user, and many of them are Windows users, they will use WSL to run Ruby and then Ruby on Rails. And to a lesser extent, that's true also of Node as well. And we'll cover a bit why I'm saying that a bit later on, but to a lesser extent, you can still have it all running natively on Windows, and with .NET it doesn't really matter. It works fine across all three, but if you're wanting to do the Ruby stuff, I'd really recommend you go down this path. All right, rant over. Next thing is text editor to develop code. I would really, really strongly recommend VS Code in this video as well, especially if you're a WSL2 Windows user. It's really, really useful editor to use in that case. If you want to develop the .NET API, you're going to need the .NET Core 6 SDK. Likewise, for the Node.js API, you'll need Node.js, and likewise for Ruby on Rails, you'll need Ruby. Now, there's a few other components, certainly for Node.js and Ruby, that you'll need to install as well. I'll cover those a bit later, but you'll need those core things to get started. This is optional. We're using SQLite database for all three APIs just to keep it consistent. You can install the SQLite command tools if you want, but that's not mandatory. And then finally, as we're doing an API or building an API, I'd really suggest you use something like Insomnia or Postman to test and work with our APIs, and I'll be using Insomnia in this video. Just another call out, all of this stuff, with the exception of the Windows operating system and the Mac operating system, all of this stuff is completely free, so just thought I'd mention that as well. All right, on to environment setup. Now, as I've said, we are working with three frameworks and each require their own kind of setup, and there's some nuances around it. So we're just going to spend a bit of time going through what you'll need to do in order to get all three frameworks up and running. Now, just before we do that, I'm going to take a look at some terminology that we're going to use an awful lot, not just in this section, but in the sections that follow. And I want to just get really clear on it because it can possibly get confusing. Some of this stuff is really obvious. Some of it is less obvious. So the first two bits of terminology I want to look at are language and framework. Language is pretty obvious for the most part. Language is just the programming language used to code the application. So in our case, we'll be using C#, JavaScript, and Ruby. Those are the languages that we are using. So what's a framework? Possibly a little less obvious than language. Often defined as tools, libraries, and conventions that allow for reuse. Used to solve or address complex problems, and they're built around one or more languages. Now, what does all that mean? Well, let's take Ruby as a language as a good example. If you're a Ruby developer and you wanted to develop an API or a web-based application, you could absolutely do that just using Ruby, and you would have to invent and create all the methodologies that would drive a web-based application, that would drive an API. That's a lot of work. Someone else somewhere has already solved that problem many, many times over, and those problems have been solved typically in a framework. And so in the case of Ruby, you will have, in one instance, the Rails framework. There are other frameworks you can use as well, by the way, but Rails is definitely the most popular one. So the creators of Rails, they've already addressed all those underlying complex problems about the fundamentals of building a web-based application. They've already cracked that, and they've come up with some rules and conventions and suggestions and approaches and libraries and tools and all that cool stuff. They've already cracked that nut, leaving you as a developer just to focus on building the value of your API, the real stuff that makes it different from anything else. The framework underlies the sort of standard layer of all APIs that are the same for all APIs. So why spend your time reinventing the wheel, basically? So a framework will allow you to get up and running quickly and build the real differentiator, the real value into your apps. And that's the difference really between a language, Ruby. You could do everything if you wanted in Ruby, but a framework just gives you that extra foot up and helps you move forward with just building what you want to build. Now, we are dealing with 3 frameworks, and even then, you could argue that Node isn't really a framework, but we'll cover that a bit later on. For the purpose of this video, I'm calling it a framework, and the language used in that framework is JavaScript. And then for .NET, obviously, you have the .NET framework, and C# is the language that we use for that. Anyway, just wanted to differentiate those 2 things. Hopefully that's clear. And I may fall into the trap of using each interchangeably. And yeah, I've just got some examples of frameworks there. As I say, Node is an interesting one. When we come on to looking at Node, we'll introduce another concept or another technology called Express, which maybe is more analogous to a framework. But we'll cover that when we do Node a bit later. And the last 2 bits of language I want to just clarify are version managers versus package managers. Somewhat straightforward, but also can get quite confusing. So what's a version manager, first of all? Quite simple, very simple actually, simple concept. A version manager is just a little bit of software that allows you to have multiple versions of some other bit of software running side by side. And it allows you to switch between those versions. So in the instance of Node, we're going to install something called NVM Node Version Manager. The clue is in the title, and that allows us to have multiple versions of Node running side by side, and we can switch between those versions. Same goes for Ruby. We're going to use something called chruby that will allow us to switch between multiple versions of the Ruby programming language. And with Ruby, it does get a little bit more complex, but we'll cover that when we come on to that section. Again, this stuff is actually covered in the cheat sheet. So I've got what version managers are being used across all 3 frameworks and what package manager is being used. So again, the cheat sheet does cover this as well. Moving on to package manager. This is much more easy. This is much more straightforward. I'm sure if you've done any development, you've used loads of different package managers. All they are a bit of software that allows you to install and manage external libraries or packages used by your app. Okay, so when you create a new app, there may be things or features that you want to use within that app that aren't natively there when you create that app. So you will use a package manager to download and install additional libraries and packages. I'm using those 2 terms interchangeably that will give you those extra features. That's really all a package manager is. And for Node, we're going to be using a package manager called NPM Node Package Manager. And again, for, if you're new to Node, you've got this thing called NVM, you've got NPM, and you've got Node. And if you're learning this for the first time, it can get a little bit confusing. So I just wanted to call out those 2 things are different. And of course, you have package managers in .NET to install .NET NuGet packages, and you have a package manager in Ruby as well to install gems. Gems are the packages that you have in the Ruby language. All right, on to the last slide. And this is really aimed at Windows users who want to set up WSL2. Mac and native Linux users, you can ignore the first few points here, but I'll call out which things you need to pay attention to. So if you want to use WSL2 on Windows, you will first of all need to install WSL2. And I have put links to all the relevant documentation below on how to do this. Most usually the official Microsoft docs that are pretty good. So install WSL2 on Windows. You'll then need to install a Linux distribution. I'm using Ubuntu. Again, I would suggest you probably go down this path as well if you want to follow along. And you just get that through the Windows App Store. It's really easy, really straightforward. And again, Mac and Linux users, you can kind of ignore this. This is for everybody. It's actually an optional step, but I would recommend you probably install the SQLite package on Linux. This just gives you access to some command line tools that allow you to manipulate SQLite, but totally optional actually, up to you whether you want to do that. If you want to build the .NET API, then obviously you'll need to install the .NET 6 SDK. Again, I put instructions on how to do that. For Mac, it's pretty straightforward. Linux, less so, but again, the documentation is in the description below. And that will give you the C# language as well. If you want to run Node, run or build the Node API, first of all, you will need to install NVM, Node Version Manager. And that's why I was talking about version managers and package managers. So install NVM. Again, I've put a doc below that will go through all the steps you need. And when we come on to doing the Node app, we'll go through and just double check that you've got all of these things installed. So don't worry, we'll kind of do a bit of a check at that point as well. So first thing to install is NVM, Node Version Manager. And then you use NVM to install the version of Node that you want. And when you install a version of Node, you'll also get the package manager with that. Okay, so you'll get NPM, the Node package manager as well. Okay, so again, if you're totally new to this stuff, it is a little bit confusing, but we'll go through it in a bit more detail in the Node section. For Rails, this is a little bit more involved. But again, this is the way I recommend you install Ruby on both a Mac and on Linux. The first thing that you should install is a little package called Ruby install. And what that allows you to do is install different versions of Ruby. Just install them, okay? But before you do that, before you actually start installing versions of Ruby, just install Ruby install. Then we're going to install the version manager, which is chruby. And chruby is the application that allows you to switch between your installed versions of Ruby. Okay, so Ruby install just to install, and then chruby to switch between those installed versions. And then finally, you will actually install the Ruby language using Ruby install. Once you get it up and running, it's a good way to manage Ruby and move between Ruby instances. Again, we'll cover it in the Ruby on Rails section in a bit more detail. Again, documentation also is all below it. It takes you through all this stuff as well. And then finally, VS Code. Really recommend you install VS Code. For WSL2 users, again, we'll go through this. You need to really install the remote WSL extension in VS Code. That just makes everything work completely seamlessly. So what it means is you can launch a version of VS Code from a Linux terminal and it will run on Windows. So graphically, VS Code will actually run on your Windows system, but really it's talking to the Linux backend, and it just makes everything work very, very seamlessly. It's very, very cool. But for now, that's the intro done for now. Let's move on to coding and building our first API. So just before we move on to coding up our APIs, I do want to just circle back on the conversation around using Visual Studio Code with a WSL2 backend. And I did mention that you should install an additional extension in Visual Studio Code. So just to show you what I mean, I'm just going to open an instance of Visual Studio Code running on Windows. So this is nothing out of the ordinary. It's just a normal instance of VS Code running on Windows. And if I come over to my extensions, you'll see all the extensions I have installed. And this is the one I'm talking about here. This is the one that you should install as normal. Nothing difficult about doing it. You just search for it and install it as you would do usually. Fantastic. So I'm just going to park this off to the side for the minute. And then what I'm going to do is I'm going to open up a Linux terminal. So into my start menu, and I'm going to find my instance of Ubuntu that I installed on top of WSL. I'll just pull the terminal onto the screen here. So this is a Linux terminal. This is my Linux instance. And if I now type code, period, this will open an instance of Visual Studio Code running on WSL2. And you'll get this nice tight integration with WSL2, as you can see down here. So it's actually saying Visual Studio Code is running in Ubuntu. It's not running in Windows, it's running in Ubuntu. And that is made possible because we've installed this remote WSL extension, okay? And probably the only other thing just to mention, just to kind of labor that point, I'm just trying to make these windows fit my largely magnified screen. If I come over to the extensions in my WSL instance of VS Code, make this a little bit bigger, you can see I've got a couple of things now. I've got what's called this local installed extensions, and these should look familiar. These are just these ones here on my local Windows install, and then you can see I have another section just in my WSL instance of VS Code for the extensions I have installed on that, okay? So again, it just shows you the differences between a Windows version of VS Code and an Ubuntu version. But again, this is, for all intents and purposes, kind of running still in Windows. It's still a Windows application, sort of, but just connected into Ubuntu. So I just wanted to cover that off. Make sure if you're using WSL that you install that extension. And if you do that, then we're all ready to move on to actually writing our APIs. So we're going to come on now and start building our Ruby on Rails API. And just before we do that, we'll do some pre-flight checks just to make sure that you have all the things that you need installed to have a successful build. So as I'm running Windows with WSL2, I'm going to open up a terminal, Ubuntu terminal, which is started on my other window. And for Mac and native Linux users, yeah, just start a terminal. If you've decided to go on your own and install Ruby natively on Windows, then yes, I'm afraid you're on your own. And the commands I'm about to run will not work on Windows, just on Linux or Mac. So the first thing I want you to check is that you've installed Ruby install. So if you type ruby-install -V, you should get something sensible back like that. If you get an error, then take a pause and make sure that you install Ruby install for your version of Linux or on Mac. Next thing I want you to check is chruby, which is the version manager, the Ruby version manager I've chosen for this video anyway. So chruby-V, and you should get something back like that. And so, as the name would suggest, Ruby install is used to install versions of Ruby. chruby is used to switch between versions of Ruby. If you do a chruby at the command line, you'll see the versions of Ruby that I have installed. I have two versions running side by side. So what I want to do now is maybe install another version of Ruby and show you how easy it is using Ruby install. So just come over to Google. If you type in Ruby language, and that will take you to the official Ruby language website, you can see all the versions that have been released. So let's try 3.04. Actually, no, let's try the latest one, 3.12. Don't want the pre-release, so we'll try that. So all you have to do is Ruby install Ruby, and I think it's 3.1.2. We might get a little warning here saying we don't know what the version is, but you can safely ignore that. I'll just type in my password and it will go away and start installing that version of Ruby for us. Now this will probably take quite a while, so I might pause the video here and we'll come back once it's finished installing. Alright, so that has successfully, or it looks like it has anyway, successfully installed this new version of Ruby onto my machine. And obviously I did pause the video just there. It did take quite a while to install. It's a non-trivial install. So what we should theoretically be able to do now is use chruby just to check and list the versions of Ruby that we have installed. So if we do chruby, interestingly, we cannot see the new version of Ruby that's been installed, and that is sort of what I expected. All we need to do, all we should be able to do, is close down our terminal and restart it in order to refresh the list of Ruby languages that we have installed. So kill that again. So restarting our terminal, I just find it here, there we go, and pull it onto the screen. And if we do a chruby, we should now see all installed versions of Ruby, including the new one we just installed. So that's the behavior I kind of expected to see. You may get slightly different behavior if you're running a Mac or another version of Linux. I don't think so though. So you can switch between versions of Ruby now by, again, using chruby and just specifying the name, or not the name, the version of the Ruby language that you want. And again, doing a chruby will show you the version that you have selected. Fantastic, so that's us installed just the Ruby language. We've not actually installed Rails yet. So let's come on and do that now. So before we do that, I'm just going to move into my working directory. So I'm going to change into season 05, change into episode 05, and it should be empty, it is. So I'm going to make a directory for our Rails code. And that's cool, and we'll change into that. And we'll clear the screen. So with our version of Ruby selected, so again, just to show you again, we're using version 3.1.2 of Ruby. If you type gem list, gems are basically the packages that the Ruby language uses. And so by doing a gem list, you can see all the local packages that have been installed here. I'm obviously not going to go through those. But just coming down here, you can see, or rather, you cannot see that Rails is not here. And Rails is just a package, just a gem that Ruby uses. So we need to install that if we want to build a Rails API, obviously. And the way we do that is by using gem install and then just the name of the package or the gem that we want. Now just before we do that, I'll just show you the package repository for gems. So if you come back to Google and just type Ruby gems. Again, this is all in the cheat sheet, including these commands that I'm doing. It includes the package repository, rubygems.org, and if we type Rails, this will just give us all the Rails type packages. And you can see here, Rails is at version 7.04 and it's got, well, almost 318 million downloads. So you can see it's pretty popular. So to install it, yeah, it's gem install. Any guesses? Just Rails. And that will install Rails at this version of Ruby. And it should be relatively quick. So it was a lot quicker than installing Ruby, that's for sure. And if we do another gem list, we should see, if we scroll up, that Rails has been installed at the latest version 7.0.4. So that's basically all our pre-flight checks kind of completed. We'll maybe take a little break here and then we'll come back in the next section and we'll actually start creating our Rails API. So back over in our working directory where we want to create our Rails API, we're going to create a new application. And so we use the Rails command to do that. And again, maybe just before we even do that, if you just do Rails-V, although we've tested it already, you should get a version back of Rails that you're expecting, which is the latest version. So we use the Rails command again to create a new Rails application. And to do that, you just type Rails, new, and you give your app a name. So I'm just going to call it Rails API. I'm going to use --API, and this will, I guess you can probably guess what that's going to do. It's going to tailor our templated project to being an API, and it will not include a lot of the stuff that we don't need or that you would expect to have as part of an API. And that's really visual stuff like, web pages, stuff like that. It just excludes all that stuff. And in a similar vein, when you typically scaffold up or create a new Rails app, it will include a lot of unit testing for you. I want to just remove that from this project. Not that I'm saying unit testing isn't valuable, but just to keep the project as small and as lean as possible, I'm going to skip including the unit testing stuff that comes out of the box. And you do that by typing --skip-test. Hit enter, and that should go away and create a new Rails app for us. Now, what you'll see here is a few things happening. Basically, it's scaffolding the app, but you'll see a couple of packages or gems being fetched, and you might go, why is it doing that? How does it know to do that? Well, before we come on to that, if you do a quick directory listing, you can see a folder's being created for us. We'll just change into that, and that will contain all our application. So we're going to use VS Code, so code period to open an instance of VS Code. And that will open our application in VS Code for the given folder. Fantastic. Now, just coming back to the point I was making about these packages, these gems being installed, and where does that come from? One of them, there's a lot of important stuff in this project, obviously, but the gem file is basically the file that lists all the gems that this particular application needs. And you can see here that it needs the SQLite gem in order for us to use the SQLite database. So basically, when you scaffold up an app, it goes through the gem file and it installs the gems that the application requires and any dependencies as well, of course. A couple of other things just to kind of point out. The main sort of application folder is in here, app, and certainly for REST-based APIs that we are creating, it follows the model view controller pattern. So you can see we have a folder for controllers, a folder for models, and one for views, although we're not really using views. The other one of interest is this DB folder, and you'll see what happens within the DB folder when we do some further scaffolding. At this point though, we don't really have much by way of an application. We've got this shell application, but there are no endpoints or anything like that. And again, if we come over to the controllers folder and we have a look at the application controller, it's just empty. You get this out of the box as standard, but it's not really doing too much. So the next thing we're going to do is we're going to use the fantastic Rails scaffold command to scaffold up a controller and a model, and which basically is going to give us our endpoints that we need for our entire API. And it effectively does all the heavy lifting for us with really very little coding required. So in order to do that, if you type Rails G scaffold, and this term scaffold, I use this term scaffold in my .NET videos. I actually just lifted it from the Rails framework. I kind of copied that terminology because I really like it. And I've also noticed that there's a lot of stuff that was in Rails that has appeared in other frameworks, including .NET. It's a really forward-thinking framework. It uses convention over configuration, which is kind of the approach we're taking here. If we want to follow the standard rules and practices of the Rails framework, which we are doing here, then setting up API endpoints is super, super easy. And this is how we're doing it. So Rails G scaffold, we want to give the name of our model effectively. So I'm just going to call it to-do or to-do model. And then we just list the attributes of this model. And I'm just going to give it one attribute, super simple, name of type string. So we're going to generate a controller and a model based around this resource here, or this model here, to-do. And to-do is going to have just one attribute. Well, it's actually going to have more. Rails will create the others automatically, but the one that we are specifying that we want is just a name string. So this would be the to-do item. If we hit enter, Rails will go away and generate a number of things for us here. You can actually see here it's created some migrations. We'll have a look at that in a second. It's created a model to do RB. It's created some routes for us, and it's also created a controller. So just taking a quick look in our DB folder, we now have this migrate folder with a migration in it. And this is basically specifying the table that we want to create in SQLite, which has not been done yet. It's just a migration file with a list of instructions in Ruby telling the migration system what needs to get created. So a table called to-do, to-dos, with a column called name, which is a string. Coming up to the controllers, you can see we've now got a to-dos controller, and then with the magic of Rails scaffolding, you can see we have 5 API endpoints now, all created for us automatically. One to get all our to-do items, one to get an individual to-do item based on its ID, one to create, one to update, and one to delete, all with typing just one command. It's pretty impressive, I think. We also have a model down here. There's not much in this. And this was probably the thing that confused me the most about Rails programming. You don't actually see the attributes in your model here by default. What you will have to look at is the migration file in the DB folder back down here to kind of have a look to see what columns and etc., what properties are on that model. And then once we migrate this, there will be a schema file here that will specify our database schema. So let's go on and do that. The last thing we want to do is just run our migrations. And the way we do that is by typing Rails db::migrate. And it will take this migration file here and migrate it down to our SQLite database. And you can see here we have a table created. You can also see that we now have this schema file, and it basically specifies the schema of our database now. So with that, we should be able to run up our API, and it should be a fully fledged, fully functional REST-based API with 5 endpoints. And we literally had to type 3 commands to get that up and running. But we'll maybe take a quick break here, and we'll come back and do that in the next section. So back over in our API, we just want to run it up and test that it's working. So we've just done our database migration. We have our schema file here. So we should theoretically just be able to run up an application, our API, and start using it. And the way you do that is by typing Rails server, or if you're lazy like I am, you can just type Rails S, and that will start up a Puma web server with our API running on localhost at port 3000. So if I just copy this, this is our kind of base URL, and I bring over Insomnia onto the screen. You can use Postman, or even for this call, you could use a web browser. I'm just going to create a new request to call this endpoint. Now we need to provide a little bit more. It's not just this base URL. We need to provide a route to where all our resources are held. So just before we do that, we come back over to our app and we look in the config folder. There should be a routes file here. And again, I think I maybe mentioned this. This is where you define your routes for your application, where your API endpoints can be found. Now, because we used that scaffold command, it's very kindly used this methodology here where it's just specifying our resources as our, well, based around our to-do model. And it knows, again, convention over configuration, that this maps to our endpoints, our 5 endpoints in our controller. So really, we're going to be looking for this route here, to-dos. So we come back over here and we add in to-dos over here. This will attempt to get all our to-do items from the API. And we have nothing in there, which is to be expected. So perhaps we do, let me just rename this. And we'll just say get all to-dos. And I'm going to create another one to create some to-do items. So maybe duplicate this. We'll say create to-do. We'll create that and we'll just change the verb to post. Okay, and so coming back to our controller, this is basically what's being hit. Our to-dos controller is being hit. And you can see down here, or up here, this was the first endpoint that we hit, get to-dos, and it will bring back all our to-dos. The next one we're going to test is this one here, which is using the post verb to create a to-do item at this route here, / to-dos. So again, it's exactly the same route, just a different verb. We'll need to supply a body though, so JSON, and we will supply some JSON. And it's just expecting a name for our to-do item, and when we say go shopping as our item for today. Fantastic, and if we send that over, you see a few things happen here. We get a 201 created back, which again, as per REST specifications, is exactly what you want. Looking in our response headers, it even gives us a location of where this resource can be found, the one that's just being created. And you can see here's the attribute, or the property name, go shopping, but we also have 2 timestamps, created at timestamp and an updated at timestamp, as well as an ID. And Rails created all that for us. Again, convention over configuration. It's pretty smart. And you can see the activity down here in the window where we added that to-do item. If we call this endpoint again and we pull it back, we can create many more. So maybe I go to the gym. Well, it's unlikely I'm going to be doing that today, but let's just add it in. Again, the ID is incremented. If we pull back all our to-dos, we get all our to-do items. Now, I did say at the start of the video, we were just going to create 2 endpoints. And for the other 2 APIs, that's all we're going to do. But because Rails does a lot of the heavy lifting for us, it's actually created 3 other endpoints for us, getting a resource based on an ID, updating and deleting as well. Very clever framework, and one that I would personally use if I needed to spin something up really quickly. Now, I do appreciate that you might think, well, you've cheated here, you've not done any coding. I haven't done any coding. I haven't done absolutely no coding, but that was the point of showing you how Rails can work and how quickly it is to stand up. You can, of course, then delve in now and start writing Ruby and making all sorts of more intricate operations with this API, but for what we're going to do in this video, that's all I'm going to do. And I will remind you, the approach that I was taking was very much this one here, the path of least resistance. And this approach for standing up a Ruby on Rails API is definitely the path of least resistance. What we've ended up with is basically a fully fledged API based on the Rails framework. So we're moving on now to our Node.js API, and just before we start doing any coding, I do just want to do some pre-flight checks to make sure that we have all the tools needed for a successful development experience. So again, I'm going to open up my instance of Ubuntu, running on Windows. I suggest you do the same. And the first tool I want you to make sure that you have is NVM. So do NVM node version manager -v to get the version that you have. And if you get an error here, please pause and follow the instructions I've put in the description below in how to install NVM on Linux. Assuming that's okay, that you have NVM installed, you can then use NVM to list the versions of Node that you have installed. So let's do that now. And again, all these commands that I'm typing out are in the cheat sheet that you can download for free. And it's a very simple command. It's just NVM ls to list the versions of Node that you have installed. And you can see I've got quite a few different versions installed, 14.16, and this one here, 16.17, which is the latest long-term support version. So if you actually come over again to Google and just type Node.js, that will, I'm sure, find the Node.js homepage, and you can see here the long-term support version 16.17 is the one that I have running, and it's the one that's selected here. That is the latest featured version one, 18.91. Of course, you can play around with that if you want, or if you want an older version, you can install that. In order to install a specific version of Node, just to clear the screen, you just type nvm install, and say we wanted to install this one here, 18.9.1, you just type the version number, 18.9.1, and again, that means you can have multiple versions of Node running side by side, but I'm not going to go and do that. So NVM is installed. The other one you'll definitely need is NPM. Now, if you have Node installed, if you've used NVM to install Node, and again, I have an instance of Node running, you should always have NPM, Node Package Manager as well. Just clear the screen just to make it less distracting. So again, just check that you have NPM installed, Node Package Manager. So npm-v. Now, you shouldn't get an error at this point. If you did, if you got some kind of weird error saying NPM is not available or something like that, you can use nvm to install the latest version of NPM. And the way you do that is nvm install -latest -npm. Okay, we'll try that and we'll see if we can maybe get the latest version of NPM. I think I already had it, 18.19.2, and it's already said I've upgraded, but it's exactly the same version. But that's what you would do. You'd use NVM to install the latest version of NPM. Fantastic. So we've already used NVM to list the versions of Node that we have. The other way that you can check to see that you have Node installed is actually by using the Node command itself, so node-v, and you can see here this is the instance that I'm running, 16.17.0. So that's all our pre-flight checks completed. I just wanted to make sure that we have everything in place before we move on to actually creating an application. So maybe we'll take a quick break here, and then in the next section we'll actually get going and we'll initialize our Node.js API application, but we'll do that next. All right, so we're going to get started with our Node API now. So back over at a Linux command prompt, I'm going to change into my working directory, which in my case is season 05, episode 05, and to do a quick directory listing, I'm going to create a directory for any Node code that I'm going to create. So make dir node, and I'll change into that. And I'm also going to create a directory for our project, for our API itself. And I'm just going to call that Node API. Change into that as well. Fantastic. So clear the screen just to give us a bit of breathing space. And yes, now we're going to initialize our API app. The way we do that is by actually using npm and then using the init command. So npm init will initialize a new Node application. And you get this kind of script that just asks you a number of questions about how you want to name your package and stuff like that. And it does pick up some defaults. It sort of picks up the defaults from the folder that you're currently in, and it's not quite got this correct. So I'm just going to call the package Node API. Version is fine, description is fine. Of course, you can add in values for these if you really want. This one here, entry point, is probably the most interesting. This is really suggesting what is the start page of our application. And I'm going to leave the default as index.js. In other tutorials or other applications, you might see the entry point as server.js or even app.js, but I'm going to leave it as index.js. nothing for test command, nothing for git repository, nothing for keywords, nothing for author, nothing for a license, and it just basically writes out some JSON to the screen with your responses here. Is it okay? Yes. So that's our application initialized, and really all it does is very, very basic. It just creates a package.json file. That is it, okay? So maybe if we open up a version of VS Code now in this folder, we'll take a quick look at that. And basically the contents of this package.json file are really just what's been written out to the screen here. If we pull that over, you can see sort of. It's just exactly the same stuff that we've already got here. Fantastic. So that's our application kind of initialized, but as you can see, it's pretty basic stuff. There's not really a lot to make up our application. It's very minimal, and this is one of the things with Node. It really gives you a lot of license to create any application type that you want. It's not like Rails, which gives you a lot of opinionated convention over configuration. Node is kind of at the opposite end of the spectrum, where you can basically just create exactly what you want, how you want. I mean, you can do that with Rails as well, obviously, but you know, the idea of convention over configuration isn't as big in Node-based applications. So in this section, we're just kind of scaffolding up and getting ready to write code. So the one thing, or the few things I want to do next, is to add some packages to our application. So we're going to be making use of SQLite. We're going to be making use of something called Express, and I'll talk a little bit about Express in a minute. And we'll leave it at that for the moment. We do have one other package that we're going to include, a couple of other packages that we'll include a bit later, but we'll leave those for now. So control backtick to get up a command line, just make sure you are in the right location so you can see your package.json file. And the first one I'm going to install is the SQLite database driver. So it's NPM, so Node Package Manager, install, and it's SQLite 3. And just be careful when you spell SQLite, it's just one L, not two, as I've often done. And the Node Package Manager will go away, and it will fetch the SQLite package effectively, and it should update our package.json file. So if we close that down and reopen it, what you will see in our dependency section is the library that we've just included. Excellent, and then the next one we're going to install is Express. So up key, and rather than SQLite, it's just Express. And in the same way, it just installs the Express package for us. And we come back over here, you'll see we have Express. Fantastic. Now, just one thing to be aware of, we've installed these packages and they are kind of local to this application. We've just done npm install Express, npm install SQLite, and we have those packages now for this particular application. You can, and I will be doing this a bit later, we'll be using another package where I'll be installing it globally, which means it's available kind of across the whole development environment. But what I've just done here is I've just included these libraries, these packages, whatever you want to call them, for our application. And what you'll also see here is that we have this Node modules folder now with a whole load of stuff in here that's been introduced because we've added these two packages. And we have a package lock.json file, which I'm not really going to cover too much in this section. So maybe we take a quick pause here. We've got a kind of basic, very, very basic app scaffolded up. In the next section, we will actually start coding, and I'll also talk a little bit about what Express is, but we'll do that in the next section. All right, so back over in our application, I did mention in the last section, we'll talk a little bit about what Express is, as we've just included it as a dependency. SQLite is, I think, pretty obvious. It's a database driver for the SQLite database. So we will be using that a bit later, but I want to talk a bit about Express in this section, and then we're going to start building our API endpoints using Express. And really, all Express is, it's really just a library that runs inside the Node runtime, and it provides us with, I guess, helper methods around all things HTTP. So it allows us to create endpoints that will deal with GET requests, POST requests, that kind of thing. Now again, like a lot of frameworks, and I guess Express is probably more analogous to a framework than Node possibly, we could write all this stuff in pure JavaScript without using Express. But Express, again, has been worked on for a long time. It's widely used. It's just solved a lot of these problems for us that many of us would encounter when building APIs or web pages or anything like that. So Express is a really useful library to make use of, and it allows us to build basically HTTP-based applications in a particular way. All right, so that's really all Express is. So what we want to do is we want to start writing some application code now, and just while we're on the package.json file, you remember from setup, we were asked to provide an entry point for our application, and we left the default, which was index.js. So all I'm going to do now is create that entry point file. So new file, index.js. Making sure you spell it correctly, and that's looking much better. And this is really the main application code for our entire Express or entire Node.js application using Express. So the first thing we want to do is actually make use of our Express library, and the way we do that is by specifying a constant. We will call it Express. You can call it anything you like, and we'll use a require statement to bring in a reference to the Express library. So require, round brackets, single quotes, Express. And again, there is a lot of great support for JavaScript, Node in particular, within Visual Studio Code, and you can even see it is suggesting the library that we want. Fantastic. So we want to now make use of Express, and we want to basically create an Express application. So the way we do that is by declaring another constant. We'll call it app, and we'll make that equal to Express, like this. Okay, so basically in here, we are just making use of the Express library, and here we are basically creating an Express app. And I'm going to create a very, very simple endpoint, a get endpoint, using our application. So it's just app, and you can see here, again, we get lots of suggestions from Visual Studio Code. Get, we want it to be a get request. And the first thing we specify is the route that we want our API to respond to. Now this is just, we're going to do this in stages, obviously. So I'm going to specify a route of API to-dos. Okay, so you'll see in a minute how this will manifest, but we'll have a kind of base route before this, and then this is the rest of the route here. We then want to specify our request and response objects. So standard notation is rec and res. Okay, so you'll see this used all the time, rec and res. Again, this is kind of Express kind of notation here. Okay, and rec is request, the actual HTTP request, and res is the response. And then using a lambda type expression, we will create the body of our get request. And all I'm going to do initially is just use a response object. I'm going to give a status, and this is where you can provide status code. So I'm going to say 200 for success. And then I'm just going to pass back some very simple JSON. And I'm just going to hard code some JSON here and just go single quotes, message, and we'll leave it at that. Now that's not as quite finished yet, so all we've done is we've instantiated a Express application. We've created an endpoint, which is not really acting as anything particularly useful, but now we want to essentially start our app and listen on a port. And the way we do that is by, again, making use of our app object. We'll use the listen keyword, and we provide a port number. I'm just going to use port 4000. You can use anything you like, so long as it's not conflicting with anything else on your system. And again, another kind of lambda type expression. And we'll just do a console log. We'll just say console log server. I'll put this in single quotes. Server running on port 4000. Keep it simple. Fantastic. We'll save that off. Cool. So all we need to do now is run this up. And the way we do that is by just typing node and then the name of the file we want. In this case, it's index.js. And you can see here, server is running on port 4000, so it's kind of listening for HTTP traffic now. And this is basically our Express/Node application up and running. So what we're going to do now is just test to make sure that we actually get a response back when we hit this endpoint. So pulling Insomnia back onto the screen, we had our stuff from our Rails exploits here. So what I'm just going to do is I'm going to create a folder here. I'm going to call this Rails. Create. I'm just going to pop these two requests into here just so we don't get mixed up. I'll close that down. Oh, close that down. And I'm going to create another folder for node. Create that, and we're going to create our first request. And again, this is just a kind of dummy one at the moment. It's not really going to do too much. HTTP / localhost port 3000, not port 3000, port 4000, and the route is API-to-dos. And we should get a response back. We do message, just comes back. So 200 response, message returned. That's fantastic for now. That's effectively the first sort of stage of our application created. So in the next section, we're going to actually start turning this into more of an actual API. But in order to do that, we'll need to get access to our database. So we're going to pivot a little bit and create some code to access our SQLite database next. So we'll do that, in the next section. All right, so in this section, we're going to come on and we're going to start writing some code that will allow our application to access our SQLite database, which actually doesn't exist yet, but will very shortly. Now, again, I keep kind of mentioning this, but I do want to just remind you, we are taking this approach, the path of least resistance. So why am I mentioning path of least resistance at this point? I did want to call out that the way I'm going to implement this code is to make direct use of the SQLite library that we installed via NPM and access our SQLite database kind of directly using that. And you might go, that sounds perfectly reasonable. And do you know what? It kind of is perfectly reasonable. However, I'm calling it out here because our other two APIs, I did or will make use. In the case of Rails, we've already done that. In that case, we use something called active record, which we didn't really explore too much in that video, but it uses something called active record to access our database. And when we come on to doing the .NET API, we're going to use something called entity framework, which again is used to access our SQLite database. Both of those things, active records and entity framework, are what are called ORMs, or object relational mappers, and they kind of sit at the layer above the database. And so the idea with an ORM is that you can use the same ORM to access multiple different types of database. So SQLite, SQL Server, MySQL, Postgres databases. You'll just use the same ORM and it can talk to those different databases, and your code will stay the same fundamentally, depending on irrespective of which database you're using. The approach we're taking here for Node is not to use an ORM, but to use the database driver directly. So what that means is we're going to write our code that's going to be very specific to that SQLite database driver. And if we wanted to then swap out the database we were using to SQL Server or MySQL, we would have to fundamentally rewrite our code. So you might be going, that doesn't sound so great. Why don't you use an ORM here? We absolutely could use an ORM here, but coming back to the path of least resistance, the ORMs I've looked at least for Node, do introduce quite a higher level of complexity. And what I'm hoping you're appreciating with Node is it is very much a blank slate. And so you really have to do all the setup yourself. And that's just going to make the video way too long. Whereas with Rails, as you saw, it does a lot of the setup for you. In fact, we didn't even talk about active record. It was just baked into the product and it's just there. Kind of similar with .NET, although not quite to the same extent as Rails. I like to think of the .NET stuff as sitting somewhere in between Rails and Node. It kind of does a lot of stuff for you, but at the same time, it gives you a lot of options to configure it exactly as you want. So in this instance, we're not using an ORM, we are using direct database code, but I just thought I'd call that out. You can absolutely, though, if you want to use an ORM. And again, in the cheat sheet, which you can download, I do mention some of the ORMs that can be used. All right, rant over, but I thought it was worth calling this out just as a point of interest. So first thing we're going to do is create a new file, because I want to put this code in a separate file. I don't want to keep it in index.js, because we may want to reuse it elsewhere in an application if it grew. So right click, new file, we'll call it database.js. And in a similar way as we did in index.js, we want to include the SQLite package. So we'll create a constant and we'll call it SQLite3, and we'll make that equal to require, and we'll just include SQLite3, and it even pulls it out. And optionally, we're going to supply this verbose setting here. That means if we get any errors, we'll get more meaningful errors. You can leave this off if you want. You don't have to put that in. For the purposes of this video, in case I get any mistakes, I want to leave it in. We then want to create a new database or connect to a database, create a database. If one does not exist, it will be created. If it does exist, we will use the existing one. So we're going to use the let keyword to create a variable called db, and we'll make that equal to new. We'll make use of our SQLite object, and we'll say database. And then we just give a path to where that database is. And you can call this anything you like. I'm just going to call it todo.db. SQLite databases, you might see them with a prefix of db. You might also see them with a prefix of SQLite, like that. But I'm just going to use db. It's my preference. Doesn't really matter though. And then we're going to catch any errors. If there's an error with that, we might not be able to access the file system. We might have some permissions errors or something like that. So we will trap that error and we'll report on that. I'll just put a semicolon there. So if we do have an error, so if error, then we'll just write that error out to the console. So console error, and we'll just say access the error object and access the message on it. And then we'll just throw that error as well, put semicolons at the end here. JavaScript is kind of weird, I think, because you don't need to necessarily put semicolons in here. You could get away without putting them in. I tend to like putting them in. As I'm a C# developer, C# would not let you do that. It would force you to do it. And so for me personally, I like to put them in. The other interesting thing, just you may be wondering, if I was writing C# code, I would absolutely write it like that. As I'm writing JavaScript code, I'm going to write it like that. I think that's generally the convention in JavaScript, but again, it's up to your style. So assuming there is no error in connecting to our database, we'll write out a success message along the lines of connected. So we use our console again. We'll say log this time, it's not an error. And we'll just write something nice to the screen like connected to db ... Fantastic. Not quite finished yet, because what we want to do is we want to create a table to contain our to-do items. And so we will access our db object. We'll use the run command, and we'll just run some SQL against our database to create a table. Now, I did mention in the start that you can install the SQL command line tools. This command, the SQL that we're going to type in now, you could absolutely run that at the SQL command line as well. In fact, it's really doing effectively the same thing. Okay, I'm not going to use it in the video, hence why it was optional, but if you want to explore it, you can do that. So we're just going to write some SQL to create a table. So create, and I'm going to have to be very careful here. Again, this is just SQL. Create a table. I'll call it to-dos. And then we're going to give it columns that we want. So we're going to give it an ID. And I might take a new line for this. And this is another interesting point. You'll see here I used single quotes here. If you want to take a new line, use the backtick. Okay, that's caught me out millions and millions of times. So if you use the single quote, you'll get like an error here. If you use a backtick, you will be able to take a new line. All right, so just one to watch. So ID will be an integer. It's going to be a primary key, and we'll auto increment. And what that means is when we create a new record in our table, we'll have our ID column, which will contain an integer value that will be auto incremented. All right. So if you use SQL Server or anything like that, it's standard behavior. And when we come on to doing the .NET API, you'll see this as well. And again, just another point, we ran database migrations for our Rails API when we did, remember, DB::migrate. This is kind of doing the same sort of thing, but again, DB migrate is part of this whole ORM active record setup. So you're starting to see the similarities actually. Fundamentally, you're creating a database, but we're doing it in a slightly different way. And again, coming back to the point, you can absolutely use an ORM with Node. We're just not doing it here. We're doing it at a more lower level. All right. And then the next property of the table or column in the table is just name. And we'll just make that a text field. And we'll keep it like that. Fantastic. So I'll just close that out. Get rid of that semicolon, and we'll take a new line, put a comma in here, and we'll take a new line. And get rid of this messaging here. So again, just to go through that again, we're using the DB object to run this SQL statement, and we'll put it across a few lines here. And I'm realizing I've got an extra superfluous single quote in there. So just backtick, and then these SQL statements. Now it's conceivable if we might get an error. And in fact, it's probably more likely we'll get an error, and it's possibly not really an error. What will happen is if the table is already there and we attempt to create it again, we will get an error. So what we'll do, we'll just trap that. And we'll just say if we get an error, then we'll just do a console log. And we'll say table already created. And we'll pause it. We'll terminate it there. And we probably have a missing round comma there. Okay, I think that's looking pretty good. All right, fantastic. The only other thing I want to put in this file is we want to make use of this code in our index.json file, in our index.json code. So in order to make use of it, we're going to export it as a module. So we'll say module exports, and what we're going to export the DB. Okay, so we can then, if we come back over here, we'll do this in the next section. This section's gone on a bit long. We'll include this database code in our index.js file, and we'll make reference to our DB object. But we'll save this off for now. We'll take a quick break here, and in the next section we'll come back and we'll start using this database code to start pulling out data and creating data using our API endpoints. But we'll do that in the next section. All right, so in this section what we're going to do is we're going to come back over to our index.js file, and we are going to create or build out this endpoint here a bit more to actually return data from our database. So this endpoint here is a GET request, and it's going to pull out all of our to-do items, and at the moment clearly it's just giving us a hard-coded message string back. But in order to use our database stuff, as I already mentioned, we're going to use the const. We're going to create a constant, and we're going to call it DB, and we're going to make that equal to require. And rather than requiring some Node package that we've required from using NPM install, we're going to make use of our database code that we wrote ourselves. So round quotes, single quotes, dot /, and again, VSCode is very helpful and actually suggests the kind of stuff that we may want to pull out. So we are going to basically include the contents of this file here, and via this module exports we get access to the DB object that we can make use of. All right. And one thing you'll just make note of is that we're including this database file effectively. There is no JS extension. We certainly don't need to put it in. It just knows that we're going to reference this thing here. And then all we need to do really is just sort of retrofit this endpoint here. And so all we're going to do is we're going to create first our SQL statement. So we'll create a variable to hold our SQL. And again, this is where, said it a few times, this is where we're actually using actual SQL statements to query our SQLite database using the SQLite driver. If you were using an ORM, you would not be using SQL statements here. And there's a whole argument, or not an argument, debate around whether this is the best approach or whether using an ORM is the best approach. And like anything in this life, there are advantages and disadvantages to both approaches, and I'll leave you to maybe doing a bit of your own research into that. But we're using raw SQL to access or query our database table. So we'll make that equal to select. This is just SQL statements, selecting everything from our to-dos table. And I'm going to put a semicolon in our SQL statements. SQL typically is also terminated by semicolons. And I'm additionally going to terminate our JavaScript statement with a semicolon. Okay, so this is our SQL here. And this is our JavaScript containing our SQL here. And just to remind you, back over in our database, when we created a table, we called it to-dos. Okay, so there's a table called to-dos. We are simply selecting everything from it. Okay, very, very straightforward. Now we're going to be making use of our DB object, this object here, to require make a call to our database and run that SQL. One of the things we do need to pass in is some parameters. I'm not going to actually make use of it as such, but we still need to pass it in. So I'm just going to declare an empty array like this. And we'll just pass that in the next statement. So take a couple of lines just to make it a bit clearer what we're doing. We're going to make use of our DB object. We're going to require all, get everything. And you can see here the stuff that it's kind of requiring us to pass into this statement, this method. So what is the SQL we want to pass in? We'll pass that in like this. We'll pass in our empty params, and then we'll require an error object and some rows that are passed back. We're going to expect possibly an error and also possibly some rows. Maybe we won't get rows, maybe we will, but we'll expect both of those to come back. And then another lambda type expression, and we will create the body of this call here. So as usual, the first thing we want to check to see is if we get an error. Was there any issue? Did the database not exist or whatever like that? And we'll write that out. Or we won't write it out. Bear in mind, we're actually getting, this is actually an endpoint, a get endpoint. So rather than writing anything out to the console, which we could do as well actually, we're just going to respond back. We're going to make use of our res object, a response object, as we did down here when we're passing back a status of 200, but this time it's an error. So we're going to pass back a res status, and we'll just pass back a 400 HTTP code. And we'll pass back this is JSON, and then we will just pass back error, and then we'll make use of our error message and pass that back, and we'll terminate that with a semicolon. Assuming there was no error, then again we'll use our response object, we'll pass it back as JSON, and in fact what we'll do here is we will just copy this, we'll cut it out, put it in here, and I'm going to take this out, this message out, because it was hard-coded, and all we're going to pass back here is our rows. Simple as that. And that is our endpoint here, our get endpoint kind of retrofitted using our DB code. So let's save that, and I can see here this was running, so I'm going to do a Control-C to stop that from running, make sure everything's saved, and I'll do an up key to relaunch our API. And it's saying connect to DB. Let me just do a Control-C, it's probably, yeah, we are connected. That makes a bit more sense. And there was another spelling mistake somewhere else down here. This one here, I did notice it. So rather than running of, it's running on. Doesn't make any difference to the functionality of an API, but it was just kind of annoying me. So let's run that up again. You can see here we've run this a second time. We've got connected to DB, and we've got this table already created. Well, I'm calling it an error. It's not really an error. So this first time, it just connected to the DB. Brilliant. Obviously created the table. This time, second time, it's telling us the table's already created. That's looking pretty good. So let's bring Insomnia back onto the screen, and we'll do a call to that same endpoint. Excellent, so we get a 200 response and we get an empty array, which is exactly what we would expect at this point because there's nothing in this database. And bear in mind, when we've done a Rails API where we're using a completely separate database, this is a database unique to our API, which I know is very obvious, but I just thought I'd mention it. So we'll take a quick break here, and in the next section we will do our post endpoint, our create endpoint, to actually put data into our API, and then we can test this endpoint again and hopefully we'll get data back. But we'll take a quick break here and we'll do that in the next section. All right, now just before we move on to doing our post endpoint, our final endpoint, I do just want to install a couple of other dependencies in our application. And the first one is not really mandatory for the running of our application. It's just something that you'll see a lot if you're doing any Node.js development, and it's a package called Nodemon or Node Monitor. And it basically looks for file changes, file saves basically, and it will restart your Node application if it detects that. So it says here automatically restarting the Node application when file changes in the directory are detected. And the reason you would want to use that is for kind of a hot reload type functionality. So anytime you save your code, it will reload the application and apply any changes. So quite nice. I find it really useful, especially in Node type applications. So we're going to install that. The second package we are going to install is one called Bodyparser. And as we are dealing with a post request now, we're going to be expecting a HTTP body with our request. And so the Bodyparser package just basically allows us, it adds it as middleware, and as it says here, it pars incoming bodies, request bodies in middleware before your handlers, okay? And it's available under the request body property within Express. So we're going to be making use of Bodyparser in our post endpoint. So let's install both of those. So I'm just going to kill my API from running, and I'm going to do an npm install, and we're going to install Nodemon first. And I did mention this, we're going to use the global flag, global flag -- global, to install this package globally, because we're going to do another little step to actually make use of it. But let's install it first. And that's been installed, fantastic. And then we're going to do Bodyparser. And we'll just install Bodyparser just for our application. And you can see it's been popped into our dependencies there, which is fine. And you see Nodemon is not there. It's been installed globally, so it doesn't really appear in our application's dependencies. Fantastic. So we'll obviously use Bodyparser in the next section, but just from a Nodemon perspective, you can actually use Nodemon to now run up our application. So Nodemon index.js. Okay, and it runs it up and the output looks slightly different. Okay, and so if we maybe changed our index file, and let's just change something really benign, let's just say running on port 4001, even though it's not, and we save that off, you can see that it restarts. And obviously if you introduce any errors or anything like that, it will be detected here. So I actually really like it. I think it's a really nice feature that you can use with Node.js applications. Let's put that back. Now, just before we move on, I did mention before, over in our package.json, you can have these what are called scripts. And so rather than running Nodemon index.js, which to be honest with you isn't really a huge deal to run, it's kind of fairly okay to run that, what you'll often see is Nodemon introduced as part of a script. So I'm going to add a script called start. You can of course call that anything you like. And then in here, I'm just basically going to paste this command. And the reason I'm kind of showing you this is because you may not particularly think this particular script is that interesting or useful, but again, it just illustrates what this script section in our package.json file is doing. So we'll save that off. And then to make use of it, you use npm start, and that will run it in exactly the same way, okay? And we can make changes to index.js and stuff like that. So it just operates in exactly the same way. Whoop. Save that off. And if you do something stupid like that and save it, you'll get errors, which I like. I like it kind of reporting back errors straight away. So a very useful tool, which I use a lot when I'm doing Node.js development. All right, fine. So I think with that kind of prep work done, in the next section, we actually will move on to doing our post endpoint or final endpoint, and we'll do that, yeah, in the next section. All right, so we're now going to come on and do our second and final endpoint in our Node.js API, and that's going to allow us to create to-do items ultimately in our database. And that's going to be a post endpoint, a HTTP post endpoint. And because it's a post endpoint, we're going to be supplying the request to our API as some JSON. So over here, you'll remember in the Rails section, if you've done the Rails section, we passed over a JSON payload like this. And in fact, it's going to be no different for our Node application. So we're going to copy that. I'm going to duplicate this. I'm going to say create to do. Obviously, this will do nothing yet because we don't yet have the endpoint. So we'll create to do, make it post. And it's exactly the same. Well, we're going to create it as exactly the same endpoint, API to-dos. And we'll give it a body of JSON, and we'll paste that in here like that. So we can close down the Rails stuff. So anyway, we had our, let me just rename this, get to-dos. All right. And this is working at the moment, so we call that empty array. We're going to create this one now, obviously. It's the same destination, different verb, and we're passing a body of JSON over with an attribute name. Now this will go nowhere at the moment. We'll get a 404 not found because we don't have it. So we're going to create that now in this section. So we did include, or we did install the Bodyparser package. We want to make use of that now in our app. So as before, we'll define a constant. We'll call it Bodyparser. And we'll make it equal to require, and no guessing what we're going to pull in, Bodyparser. Let's just try that again. I want the laziness of IntelliSense to help me out. Okay, so const Bodyparser. What we then want to do is use Bodyparser as part of our app and add it to our app's middleware. So make sure you do these next few lines after our declaration, after the creation of our Express app. And what we're going to do is we're going to use our app object, use, and we're going to use Bodyparser. We're going to add it to its middleware. So use the Bodyparser, and the first thing we want to allow it to handle is URL encoded bodies. And we'll just pass over a bit of extra config, and we'll say extended equals false, or is false in this case. Okay, we don't want extended to deal with extended payloads. And we'll also use JSON as well. So again, app use Bodyparser again, and this time you just want to use JSON. Okay, and so again, I've said this already, Bodyparser just allows us to parse the body of our inputs via our HTTP requests. So parse this stuff here basically in an effective way and allow us to kind of drill in and pull out attribute names or property names. Let's save that off. And again, we've got Nodemon still running. So if we'd introduced some crazy error, it would have errored out, but that's all looking good. So we can now move on to our endpoint. So again, here's our first endpoint. It's a GET request. We're now going to create a POST request. So no guessing what that's going to be, at POST, like that. And in a similar way, or exactly the same way, we're going to specify the route as API to-dos. Exactly the same as the GET request. But these are two distinct endpoints because they have different verbs. Okay. And then we're going to use our rec and res objects as before. And we're then going to come on now and define the body of our endpoint. So this next step is probably good practice, but it's not strictly mandatory. But I'm going to create a variable, actually an array of errors, that we're going to place any validation error messages into. And this is purely kind of manual validation, but it kind of demonstrates one of the uses of Bodyparser. So what we're going to say is if not a request body. Now remember when we talked about what Bodyparser was, it said we are able to parse bodies on our request object, and that is all we are doing here. And we're going to specify that we want to check to see if there is a name property being passed in. Okay, so here we're saying if there's not a name, hence the bang, then we're going to basically add an error to our collection. And the way we do that is using our errors collection, our errors array, and we're going to push on a message to say something like no name supplied. Okay, so this is really sort of manual type validation. There will be other validation libraries and frameworks that you could use as part of Node.js, but we're just going to keep it really simple today. Again, the path of least resistance. We're then going to check to see if our errors collection is empty or not. So if it's not empty, then it means we have errors, and we're just going to respond with a status of 400, so not successful, and then we'll just supply a little bit of JSON back. And what should we say? Something like error. And we want to supply back whatever is in our errors array. So we'll do a join, and we'll supply a comma like that. And of course we don't want to progress, so we will return. Don't want to go any further. So we'll save that off. Again, Nodemon is reporting no issues. So for JavaScript, I really, really love Nodemon, as you can probably tell. So a little bit of sort of validation stuff, you could potentially leave that out if you really wanted to, but I think it's nice to have it in here. The next thing we're going to do is create an object that's just going to contain the data that we want to pass over to the database ultimately, and we'll make use of this a bit later, so that's really why we're creating it. So data object, and we're just going to specify a name, and we'll make that equal to the request body name attribute. Okay, so whatever's passed in the name, we're just going to put it into this object called data with one property, which is name. Okay, fantastic. Then I'm going to create another variable, this time holding the SQL that we're going to use to insert a row into our table. So this is raw SQL, so insert into to-dos, and to-dos is the name of our table, remember. The column name we're going to target is name, and we'll specify the values that we're going to place in there, and we'll just use a placeholder question mark like that, because we'll inject, fundamentally we'll inject this value here in of name. And of course, I've kept this super simple for this tutorial. You could have, you know, multiple properties, so maybe not just the name, but the date of the to-do item was due and whether it was complete. That would all go in here. We've just kept it super simple, so it's maybe slightly overkill for what we've got, but it's kind of giving you a foundation for moving forward. I'm going to put a semicolon as part of our SQL statement. SQL will still generally execute without a semicolon, but I'm trying to be a good citizen and include it. And I'm going to terminate the JavaScript command with a semicolon as well. Then I'm going to specify some parameters. And this is effectively just the data that we want to pass over. So params is another array. Very simple this time. We're going to make use of our data object and just pass over the name. Again, if you had multiple parameters, you would pass them in here as an array. So it just sets us up for a more complex model, basically. Excellent, so let's save that off. Still no errors, that's pretty good. And then we're going to make use of our database again. I'm going to run our SQL command. So run our SQL. This time we have some parameters. We didn't last time. Well, we still passed it in, but we had no values in there, but this time we do. And that's basically just going to fundamentally inject the value of this into here. That's all it's really doing. Then I'm going to specify a return function with an error object and also a result. And that will look a little something like this. I'm just going to terminate that. Remember my semicolons. Oh. So if we do have an error object, then we're going to return a result, kind of as we've done before, the status code of 400, and we'll provide some JSON, and we will say something like error, and we will give the error message. That needs to be outside the double quotes. So error message. All right, so if something went wrong with the insertion for some reason, then we will provide back a message. And I'm just realizing this is erroring out. If we try to save this off now, for example, we're going to get an error, which is kind of nice if we didn't spot this here. And it's just because I forgot to put in some curly brackets because we're basically passing back some JSON. Save that off again. And the lights are green once again, which is good. So assuming we get to this point, we're almost done. We have a successful result. We want to pass back a result with a 200 status. And as per kind of general REST convention, you want to pass back a 201 created result. And then we just want to pass back some JSON. Don't forget the curly brackets this time. And all I'm going to pass back is the ID of the newly created resource. And this is a little bit of SQLite driver magic. I want to get the last inserted ID. The ID is, if you remember, auto-incremented. Okay, so basically SQLite takes care of it for us. So to get that value, we use this and the last ID property, like that. And that will give us the last inserted ID. And then finally, whatever the value was. So name is going to be whatever's ever in data name, like that. Okay, so kind of quite manual coding. There are other ways to kind of streamline this and automate it, but again, path of least resistance is kind of doing some low-level database stuff. That should be us, so let's save that up. We have saved it off. There's no errors, which is looking pretty good, so let's bring up Insomnia and we'll test this baby out. So we had tried to run this previously, go to the gym. I actually did go today, so can maybe change that, but let's change it to something like have dinner. Which I have not done yet, and I'm getting quite hungry. And let's see if this works. Error. Okay, so we're getting an error. SQLite error near value. Okay, let's take a quick look at that. Okay, I've just misspelt this. It should be values, not value. Okay, and anyone who spotted that, good job, you get 10 gold stars. So let's try that again. There we go. Have dinner, and if we do get all to do's, send that over, have dinner, perfect. And we'll just do one more just to double check. Do the .NET API video which I'll do that next. I'll just make sure that works okay. Looks good, and again you can see the IDs being incremented, and you know we have the name. Unlike we've still got the cached responses, unlike the Rails stuff, we didn't have a created at updated timestamp because Rails added that for us. If we take a quick look at the response headers, again we've got a location here provided to us by Rails. If we come over here, we don't have that as part of our Node application. Not to say that we can't add that, we could add all that in, but the point I'm making is that Rails kind of did so much stuff for us out the box without really having to do anything, whereas with Node it takes a different approach and it really puts the keys, gives you the keys to the car, and you have to drive the car exactly as you want to drive it. So yeah, you really have to drive it as you want it. Not to say that you can't do that with Rails, so I really want to stress that. Although Rails did a lot for us, it's not to say that there's no coding with Rails. Of course there is. You can do as much as you want. It's just that to get started initially, there's a lot less effort. So that's our Node API completed. Obviously you could extend it as much as you want, but for what we're doing here, that's it completed. And so in the final section, we're going to move on to my favorite topic, my favorite framework, the one I'm most familiar with, which is .NET. So in the next section, we're going to do a .NET API. But yeah, we'll do that next. All right, in this last section, we're going to write our last API, and that is, of course, a .NET API. So just want to do some pre-flight checks just to make sure we've got the .NET framework installed. So just bring up another command, prompt or terminal more correctly, and type .NET -- version, and you should get version 6 come back. If you get some kind of error saying unrecognized command, then you will need to install the .NET 6 SDK. If you get a successful return but at a lower version, say 3 or 5, you will need to install version 6, as we're using a feature specific to the .NET 6 version. And that's it. That's how simple it is. You just need to install one thing, and with that you get the C# language as well as the entire .NET framework as well. So it's much simpler than either of the other two frameworks that we've been working with in terms of installing it anyway. So next thing we want to do is just move into our working directory. So season 5 for me, episode 05 for me, quick directory listing, and we'll need to make a directory for our .NET API. I'm just going to call it not .API, .NET. All right, and we'll change into that. Typing's letting me down now. And then what we can do is we can use the .NET command again, new keyword -- list, and this will list all the different project templates that we could use to scaffold up a new application. And the one that we are going to be using is this one here, the Web API template, as we want to build a Web API. So we'll clear the screen and give us a bit of breathing space, up key, take out -- list, and we'll use the Web API template. This is the new feature I was talking about with .NET 6. We'll use -minimal. And that means we will get a Web API, but a minimal version of it. And really fundamentally what it means is we're not going to get a controller, as in a model view controller that follows the MVC pattern. So no controllers or endpoints will just reside in the main part of our API. So it's lighter weight, quicker to build, path of least resistance. And then finally, we just need to give our project a name. So I'm just going to call this .NET API, following the naming convention of our other APIs. Done very quickly, do a quick directory listing, and we have a project folder. So let's just change into that. And we will open it in Visual Studio Code. So just type code period to open the contents of this folder. Fantastic, and we'll probably get a pop-up down here asking us, yep, if we want to build some missing assets, just click yes to that. So we'll quickly go through the structure of the project. As you can see, it's a lot less complex than the Rails API, but slightly more complex than the Node API. So it sits somewhere in between. Now, the CS extension means it's a C# file, and the program class is really where we're going to be doing most, if not all, of our coding. There's some code in here already that's really just for a templated application. We're going to take that out in the next section. We'll leave some stuff in though, but for the most part, we'll get rid of pretty much all of this stuff. The CSproj file is the project file, and really for our purposes, we're really only interested in that when we come to looking at the item group and the packages that our application is going to use. So we'll install some packages in just a bit, mainly the one for SQLite database. It was a package that we will need to install. These two files here, the app settings JSON files, they are, as the name would suggest, files where you can put configuration. So typically if you were connecting into a database and needed a connection string, it would more than usually go in here or could go in here. And the only difference between these two is that this one is just consumed in a development environment only, whereas this one is consumed in all environments. And then the only other file worth quickly looking at is this one here, launch settings JSON. And again, as the name would suggest, this file's kind of run at the point when we start our application and we get some additional config. So for example, the development environment, the environment that we want our application to run in. So here we are setting it to development. You could change this to production or something else, but by default, we are running our API in development environment. The other thing of interest is the endpoint URLs here. So we get both a HTTPS and a HTTP route or endpoint to our API, and we can use either of these. That's about it for this file. I am just going to take out a couple of bits of config here. So this launch browser, we don't want to launch a browser when we run the API as it is an API, and I also want to take out the launch URL. So remove that, and I will also do that down here as well. Now, you might be wondering what are these kind of three groupings of things? These are just different profiles, and each profile will be selected depending on where the API is being run. So as we are running the API at the .NET command line, this kind of profile will be chosen and we'll get these URLs and additional config and stuff. So I'm not going to go into too much more detail about that, but that is looking pretty good. So we'll maybe take a quick pause here, and in the next section, we'll install the additional packages that we need to move forward with an application, but we will do that in the next section. All right, so in this section, what we're going to do is we're going to install a couple of packages that our application is going to use, so we can use the SQLite database. And then we're also going to come over to our program class, and we're going to tidy this up a bit. When you scaffold an application, you get some example code that we're just going to get rid of. We'll get rid of the most of it anyway, and we'll replace it with our own code. So we'll do those two things. So first off, we want to install some packages. And in a similar way with Ruby, where you had the Ruby Gems repository, and with Node, you had the NPM repository, for .NET, you have something called NuGet. So we just search for NuGet in Google, and you come to the NuGet gallery. It's a similar idea. You can just search for packages here that you may want to use. So we're wanting to make use of SQLite. Search for SQLite. There are a whole bunch of packages that we could use, which may be confusing for new users. So to help you out, I will tell you which one we are going to use, which is this one here. Microsoft package. You can see it's got almost 82 million downloads, and it's the Entity Framework Core package for SQLite. And you may recall I talked about Entity Framework, which is basically the Microsoft ORM, or Object Relational Mapper. So the idea is you can use Entity Framework Core to access a whole range of different database types. And as we're using SQLite, this is the package that we are going to use. So we click in that. It gives you some options about how you can install it. So this option here, Package Manager, this is something you get if you're using the full-blown version of Visual Studio Package Manager console. Or you can just copy and paste this code and paste it directly into your CSproj file, kind of like this one here. We're not going to do that. We're going to use this option here, the .NET CLI option, which will use the .NET add packages command to add the package. So let's copy that. And back over in Visual Studio Code, do a control backtick to get a terminal up and running. And we're just going to paste that in, but don't run it just yet, just paste it in. Because what I want to do is take out this version. You can see here, it's specifying version 7 point blah, 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 blah. That's a pre-release version that's kind of mapping over to .NET 7. I don't want to use that. I want to stick with the production version of .NET, which is .NET 6 at the moment anyway. So by taking out the version, you let the package manager determine what is the most appropriate version for us. So hit enter on that, and what you should see is the package reference being added to the CS proj file. So I like doing that so I can see the package references being added. Sometimes you may mistype one of the package names and it may not add correctly and you won't actually see it here. So it's just a nice double check. Now we do want to install another package. So just delete up to the period here, get rid of SQLite and just put in design. And this is just another support package that allows us to use Entity Framework Core. And if you just move that up, you can see it's added in the design package as well. Now, we did kind of remove a couple of things from our launch settings file, really in reference to launch URLs and stuff like that. What I also want to do is actually take out this reference to this package here because we're not using it. And I'm not even going to talk about what it is because it's just going to be confusing. We don't need it to talk about it for now. So we'll just take that out and save the CS proj file. Fantastic. So the other thing we wanted to do is that's the only packages we need to install for our application, just stuff related to SQLite. So that's the only stuff we need to install, so that's pretty cool. The last thing I want to do in this section is take out some of the dummy code. Not all of it, but most of it. So I'm not even going to go through what it is because it's just, you know, again, path of least resistance, it's not worth going through it. So just follow me and take out this record. Leave in this line here, app.run. This code here is basically an endpoint, but we're going to create our own, so just take out all of that. These summaries, just take this out as well, we don't need that. Leave in this line here, use HTTPS redirection, and I'll talk a bit about what that is in a minute. Take out this stuff here, we do not need it. Leave in this line here, var app equals build, and also take out these two lines and these two comments. So it should leave you with 4 lines, fairly minimal, but it's kind of the bare minimum that you will need to run an application. So from the top down, basically what's happening here is we are constructing an application, okay, using this create builder method here. And that gives us this builder object. And then finally, what we want to do is we are actually going to do some stuff in between here, in between these two lines, this line here and this line here. And this final step is just finalizing the build of our app. And we actually end up with this app object that we continue to use throughout the rest of this file here. So it's almost like almost 2 sections here. So this is kind of the build stage, building up our app, and this is kind of almost sort of running our app, okay? And what we're going to do in here is we're going to do some stuff a bit later, but I won't talk about that just yet. Once we have our app up and running and ready to go, we are using this thing called HTTPS redirection. And what that means is, come back to launch settings JSON, we are going to have 2 endpoints, a HTTPS one and a HTTP one. And if we hit our HTTP endpoint in our browser, what will happen if we have HTTPS redirection enabled is that we will automatically get redirected to the HTTPS endpoint, as it's obviously secure. So that's all that this is doing. So definitely suggest you leave it in. And then finally, we just run up the application, and that will then give us an application that's running on those endpoints. Fantastic. So I think that gives us, that's enough scaffolding done. That's basically us just taking out redundant code, we've added our packages. In the next section, we're actually going to start writing some code. And the first thing we're going to do is creating our model, but we'll do that in the next section. All right, so we're going to come on now and create our model. So back over in our project, right click within the Explorer, the file Explorer, and we're going to create a folder. And we're going to call it models, okay? And again, you know, just rename that to what I actually want. Again, with something like Rails, you already had a models folder within the app folder. It did all that for you. Within the .NET domain, you kind of have to do some of this stuff for yourself, which I actually don't have a problem with, to be honest with you. So we're going to create a model, and again, a model is just a class that represents the data that we want to work with. And so we are going to be creating a to-do item, a to-do class. It will have an ID that represents our primary key in our database fundamentally, and then just a the other property is just going to be a name, a string that represents the thing that we want to do. So we're going to represent that as a C# class. So within our models folder, right click, new file, and we're just going to call that todo.cs. Fantastic. So we'll start with defining a namespace. And the best way of me describing what a namespace is when we actually come to using a namespace. So I'm going to just type the code, and you'll see, you can probably guess what it is, to be honest with you, but I'll explain it when we come to using it. It's really just, fundamentally, it's just a way to organize your code. It's just a way to name where you want your code to reside. That's basically it. We then want to specify a public class, and we'll call it todo. Capitalize the T, curly brackets, and we want two properties. And the shorthand way of defining properties is to type prop and then tab. And it's saying that we have a public property, fantastic, of type integer, which we do. So tab over and then give it a name. And we're going to give our first property the name of ID. And it's just a getter and setter property, so you can both get it and set it, read and write it. Second property is going to be a string of type name. Okay, so it's exactly the same two properties that we've used in our other two APIs. No different, just obviously defined in a slightly different way. We're getting a warning here, and this is a kind of sort of a new thing, a new mandatory thing that's kind of come in with .NET 6, where we just get more nullability checks. Okay, so it's, as you can see there, it's saying a non-nullable property must contain a non-null value. Okay, so it's essentially saying, you know, this could end up being null. At the moment, you're saying it cannot be null. So I just want to get rid of that warning. And the way you do that is just by putting a question mark here, saying actually, this could legitimately be null. And that's what the question mark does. Now, fundamentally, what we're going to end up doing with this is migrating this in a similar way as we did with Rails. We're going to migrate this down into our SQLite database. So there's a bit of work to do in order to get that to happen. But before we do that, I want to just put in a little bit of additional config here to tell that migration process how we want this to be represented down in our SQLite database. And the main thing I want to just specify, although I don't actually have to, is to say that the ID is going to be a primary key in our database. Now you'll remember Rails did that for us automatically. When we did our Node API, we had to specify that in the SQL that constructed the table. But we're going to be using migrations here. Now actually, Entity Framework is good enough, intelligent enough, actually using convention over configuration. When it sees this, it actually knows that we intend this to be a primary key. And we don't need to do this step that I'm about to do. I just like to do it because I feel it makes our code a bit more readable. So what we do is we decorate our property with an annotation of key, and it's just saying, yep, we want this to be a primary key, although technically we don't really need to do it. We're getting an error because we don't know what this key means or is, so the way to see what we can do to remediate that error is by placing your cursor in it, holding down the control key, period, and you get these suggestions about how we can remediate this error. And I just want to bring in a using statement at the top, using system component model annotations, and we get rid of the error. All right, so we'll save that off. And this is specified well enough. You can add loads of other annotations. I'm not going to bother doing that. Fantastic, so that's our model complete. We want to fundamentally migrate this down to our SQLite database, but there's one piece of the puzzle missing, and that's a thing called a DBContext. And what a DBContext does, it's an entity framework concept. It acts as the mediator between our model, which is really just a class. Looking at this, you don't know it has anything to do with a database. It's really just a class. Our DBContext will take that when we come to migrate it, understand how it's composed, and then basically mediate it down to our SQLite database. So we need this joiner in the middle, this mediator in the middle, which is our app DBContext. So we're going to do that in the next section. All right, so we're going to do our app DBContext or our DBContext, and I'm going to create another folder in our project at the top level. So new folder, I'm going to call it data. So anything in the data folder really refers to our data layer, and our DBContext, in my mind, sits in our data layer. So I'm going to right click, new file, and I'm going to call it app DBContext. DBContext.cs. It's just another C# class. We'll also give it a namespace, so always using the name of the app followed by where it is residing, so it's sitting in data this time, not models. And start a new line. It is just a public class, as before. Call app DBContext. But this time we want to do something a little bit different, and we actually want to make use of a pre-existing class that exists within the Entity Framework Core ORM, and that is our DBContext class. So Microsoft have already created this DBContext class. We basically just want to say, yep, we'll have one of those and we'll create our own one of those things. So the way that you notate that is by using a colon and then just the name of the base class that you want to use. So DBContext is what we want. Now again, it's complaining, it just doesn't know what DBContext is. So as before, control period, and we'll bring in the Entity Framework Core namespace. All right, new line, curly brackets. Now, going into object-oriented programming is a little bit outside the scope of today's video, but if you've done any object-oriented programming and you understand what a class is, a class can have something called a constructor, and a constructor is basically just the method that runs when that class gets created. It's the first thing that kind of gets run. So we do need to create a class constructor as we are implementing the base class here. So it's a requirement. We have to create almost like an empty constructor. So you can type CTOR, not CTOT, CTOR and tab, and that will create a kind of placeholder constructor for us. And you can see the name of the constructor is the same as the name of the class. And we just need to kind of create a bit of a method signature here that is in line with what the DBContext class expects. So we need to supply some DBContext options. We need to tell it a type, which is the angled brackets, and the type is just our class at DBContext, and then options. Then finally, we're just specifying the base keyword for base class, and we will say options as well, like that. And that's all we need to do. Now, I know that's a little bit obscure, just trust me, we need to do it as we are implementing DBContext. But the most interesting thing and the most important thing about the DBContext is basically it's, again, going to tell our database, SQLite in this case, what classes we want to migrate down or we want to mediate down to our database. Now, we could have a whole bunch of classes sitting in an application. I've just created one, to do. We could have 10 more. We may want to only migrate some of those down to our database. So what we're going to do next in our DBContext is specify something called a DB set. And all a DB set is saying we want to take this particular class, in this case our to-do class, and mediate it down as a table to our SQLite database. So that's what we're doing in this next line. So specify it's public, it's a DB set. What type is it? This is where we specify our class, which is just to-do, which is just this class here. And we want to give this DB set a name, and we're just going to call it to-dos, and that will end up being the name of our table in our database. Okay. And then we just finalize that off, so we'll just set that to a given type of to-do. We'll finish that off. Now it's complaining because it doesn't know what the to-do is, doesn't know where it is. Even though it's in the same app, it doesn't know where it is. So we come in here, control period, and this is circling us back to the use of namespace. As you can see here, it's saying, do we want to use .NET API models, which is the namespace I specified for our to-do class. And indeed it is. So we just get another using statement up here. And again, just to remind you, this is just our namespace here. Okay, so it's just a way to help us understand where classes are coming from, where they sit within our app. It's just a nice way to organize them. All right, so that actually is our DBContext done. We'll take a quick pause here. It's not quite finished though. The class itself that we've just set up is done, but we need to actually tell our application that we want to make use of it. So we'll do that in the next section. All right, so in this section, just following on from the creation of our DBContext, and by the way, just remember to save it. I haven't saved it, so cool, save it. We're not going to make any more changes to this, it's done, but what we want to do now is actually register it in our program class. Now, I did talk about these two lines here. This first line is kind of kicking off the build of our application. And this one here is finalizing the build of our application. And in between these two lines, we can do all sorts of things. And one of the things that we need to do to get this application to work is register our DBContext here. And what that's effectively doing is it's registering it in something called a container. And that means we can call upon that container to give us an instance of that DBContext anytime we need it. And our endpoints that we're going to write in the next section will do that. They'll go, hey, we need an instance of this DBContext because it's used to actually access our database as well. So all we're doing here in this step is registering it. It uses something called dependency injection, which is a whole other topic way outside the scope of this video. If you are interested in learning more about dependency injection, there's a free module in the .NET Developer Toolkit course on lesjackson.net. The same place where you can get the cheat sheet and you can learn all about dependency injection, absolutely free over there, but slightly outside the scope of today's video. So all we need to do here is a bit of a long line of coding, but it's relatively straightforward. We want to make use of our builder, services. So ultimately this is being registered as a service. We want to add a DBContext. And there should be a method for that. We just need to tell it what type we're expecting, and it's just the type of our class, which is app DBContext. And then we just need to pass through some options. And really all we're telling it is where do we find our database fundamentally. So OPT goes to OPT. In fact, I might take a new line for this. And we want to tell it to use SQLite. We will need to bring in a namespace here. And then we just need to specify where we can find our SQLite database. Before we do that though, I'm just going to bring in the namespace for this. So again, here's our namespace where our app DBContext resides, .NET API data. Fantastic, and it still doesn't know what use SQLite is. So again, using Microsoft Entity Framework Core. And what we need to put here for this method is basically a location where we can find our SQLite database. And that's really just a file path to where our SQLite database can be found. We don't have one yet, but again, like with Node.js, one will get created when we spin our application up. And the way we specify that is by saying data source. And this is kind of like a connection string really, equals to do DB. And again, we can give this is just the name of our database. You can give it any name you like. We do need to specify this data source parameter. Now we could, and I have done in previous videos, taken this particular bit of config and you can put it into one of these files here. And then all we need to do is read in that config into here. But I'm just going to hard code it directly into this method. Probably not best practice. You could put it in here and then read it in. In fact, do you know what? Let's do it. Let's do that. Let's not be lazy. So what we can do is we can put it in our app settings development JSON file. And what we want to specify is a property called connection strings. And then inside connection strings, we'll give our connection string a name. So we'll say SQLite DB, and then we'll give it the actual value. And so I'll come back over here and I'm going to copy this out, cut this out completely, just to demonstrate this. And we'll put it in here as our value. Okay, so cool. So that's showing you how you make use of these app settings development, app settings JSON files. We're using the development one. You could actually put this in here as well. It would also get read in, but I want to keep it unique to our development environment. So that means, what do we put in here? What do we put in for this method? How does it know where to get that? Well, it's quite easy. You make use of a builder again. We make use of something called configuration, which is the configuration layer. And then we make use of a method called getConnectionString. And into that method, we just pass the name, I put it in the right place, the name of our connection string, which if we come back over here, this is the name of our connection string here. I don't want to copy the double quote, that. Okay, and we had to use this property name here, connection strings, in order for us to use this method, getConnectionString. It's kind of tied, paired with that. Okay, and that will give us the value of this basically. Okay, so probably worth doing. I was going to be lazy and do the path of least resistance, but I've gone a little bit over the top and done it in a more productionized way. Fantastic. So that's it. really, for now. We have just created our DBContext and we've now registered it. Before we move on to doing our endpoints though, we need to migrate all this now. So we've joined all the dots, we've got our class, we've got our DBContext, we've registered it, we've told it where the database is to reside, so theoretically we can migrate this down to our database now, but we'll do that in the next section. Alright, so what we want to do in this section is migrate down our model to our SQLite database. Now you'll remember when we scaffolded in our Rails API, we scaffolded up our model in our class. We also got a migrations file as part of that bundle of stuff. We don't have that here, so this step we're about to do is actually to create that migrations file that we will then migrate. So in Rails we did db::migrate. There's a second command we will run here to do the same thing. But first we need to just generate our migrations. Now, I'm going to reckon that I'm going to get an error here when I run this command, but let's give it a go and see what happens. The command you want is .NET EF. EF stands for Entity Framework Migrations, add, and then we just give the migration file a name, so initial. Hit enter. So we do get an error, and the reason is that it does not know what this EF command is, no idea what it is. So we do actually need to install some additional tools to allow us to use that command. And the command we need is .NET tool install --global .NET -EF. And that will install the .NET EF command line tools, which was missing, okay? So, very important step. So if I do up key again, and we try and run this command now, it should be successful. Unless there's some other error, but it looks okay. And what you'll see is we have a new folder created called migrations, and inside of here we have a few files, but the one we really want is this one here. This is the migrations file, and it's not too dissimilar to the migrations file that we had with Rails. Of course, this is C# code and not Ruby code, but it's exactly the same concept. It's just code that specifies what table we want to create, what columns in the table we want to create, is it a primary key, so on and so forth. And again, this is specific to the database that we have selected. So we installed the Entity Framework Core.SQLite package. This is the migration file we get because we're using that. If we were using Microsoft SQL Server, we'd still get a migration file, but it would look slightly different. Okay, hopefully that made sense. So we still don't have a database, we just have a migrations file. And so now what we want to do is actually migrate down. So this command is analogous to the Rails command db::migrate. Slightly different, obviously it's a completely different platform, so it's .NET EF database update. And assuming it's successful, we should see a database being created. Indeed we do. We get a to-do DB, which is just a file, but it's a SQLite database. And you can see a whole bunch of SQL commands being executed. So that is looking very good. I'm very confident we've done everything correctly. If you had any issues there, you wouldn't get the database created and you wouldn't see SQL commands there. So that's all looking pretty good. So in the next sections, we're going to actually create our API endpoints. We're going to create two, a GET request to get all our to-do items and a POST request to put our items in. But we'll do that in the next section. Alright, so in this section we are going to do our endpoints. We're coming to the end of our build. So I'll just go to the terminal. I'm going to get rid of this comment here. I'm going to just get rid of some of this white space. And I'm going to take a new line after the use HTTPS redirection, but before our app runs. So we're going to write our endpoint code in here. We're going to do two of them. So we're going to use our app object, and then we're going to use the map get command to create a get endpoint. Now this will actually look very, very similar to what we did for Node when we did our Node endpoints. Not exactly the same, it's a completely different language, but it's not going to look too different. The concept's very, very similar. So map get, and the first thing we want to do is specify the additional route to this endpoint. So I'm going to specify API /to-dos, And then we're going to specify the rest of our method. And it's going to be an asynchronous method. Again, asynchronous programming is kind of outside the scope of this video. It's to do with thread exhaustion basically, but nonetheless, we'll leave that there. So we use the async keyword to say this is an asynchronous method. We are going to make use of our DBContext now because our endpoints need to know where to get data from, and they do that via our DBContext. So we're going to say, hey, we want an app DBContext. We want one of these, but we want to give it a name. Call it context. Okay, so we actually make use of this object here, context, but it's of this particular type. And we know where to get this app DBContext from because we've registered it up here in our dependency injection container. And then we just define the rest of our method, and it's pretty straightforward. Before we do that, I'll just put a semicolon in here, and the body of our method is pretty straightforward. We're going to create a variable of to-do items, and we want to just get our items from the database. So we're going to use the await keyword. Wherever you see async, we need to pair it with an await keyword. We'll make use of our DBContext. Our DBContext is aware of our to-dos collection. And then we just want to return that as a list. And we want to use the asynchronous method, like so. So wherever you have these asynchronous methods, you need to use await, and it has to be paired with, it also has to be paired with an async keyword up here. So that's only going to our DBContext, which is then in turn going to go to our database and give us a list of items if there are any. There might be none, might be empty, but nonetheless we want to return that result. So we use the return keyword, make use of results. We're going to make use of the OK method, which just returns a 200 HTTP result, and we'll return our items as part of that. That's it. Pretty straightforward. We don't have to do anything else. Again, there is a bit of convention over configuration here. We're just going to get a JSON payload returned back based on any items that we have in our API. So what we might do is we might save that, and we might run it up and test it. Now, we won't get any items returned, obviously, because it's going to be empty, but if we do a .NET run, if we have any errors, we should see them here. But what you'll see, and you're seeing this for the first time, you can see we have two endpoints. We have a HTTPS endpoint running on port 7222 and one for HTTP. It's also running in development environment. Okay, so we'll bring Insomnia back onto the screen and we'll make a call to our get endpoint. So back over in Insomnia, I'm going to create a new folder for our .NET stuff. So new folder, .NET, and I'm going to create a new request, and I'm just going to rename it. Let's see, get to do's. Great. And come back down here, and I'm going to pick our HTTPS endpoint, copy that, and paste it into our URL field. And then just to remind you, when we defined our endpoint, although it was only about 2 seconds ago, so you should remember we specified this route here. So I'm just going to copy that as well. Okay. And paste that in here, like that. If we click send, you see some activity down here. You know, we've used our DBContext to reach out to our database. You can even see it's done like constructed a SQL statement for us. We didn't write that SQL statement. Fundamentally, Entity Framework constructed that SQL statement for us, as opposed to Node, where we had to write the low-level SQL. And we got a result back, 200 result with an empty array, because there's nothing in there. So that's looking pretty good. So maybe take a quick pause here, and then we'll come on to doing our last endpoint, which is to create items in our database fundamentally, but we'll do that next. So in this last section, we are going to write our final endpoint, which is our create endpoint, our post endpoint, to post data to our database fundamentally. So I'm just going to do a Control-C to stop our application from running. If you had it running, I'd suggest you stop it as well. And just before we start writing code, let's just come back to Insomnia. I'm going to duplicate this. I'm going to call it create to do. And I'm going to change the verb to post. Again, just to remind you, we're doing a post to the same endpoint. And if we just come down to our previous endpoint requests, I'm going to copy the body text out of our node post request, because it's going to be identical. So come back over here, select JSON and paste it in. Okay, so again, just to refresh you, we're now going to post to our .NET API, and we're going to post this body as this JSON body over to our API. All right, so the way we do that should look quite familiar. I'm sure you're going to guess half of this. Map post this time rather than map get. And we're going to specify the endpoint route, so API to-dos, fantastic. And then in a similar way, just want to get rid of this code tips there. In a similar way as we did above, we're going to specify it's an asynchronous method, and we're going to want an app DBContext called context, because we're going to put data into our database, so it's exactly the same as before. But unlike the above method, where we're just pulling data out of the database, here we are expecting to get sent this. So a bit of convention over configuration comes in here as well, in that we specify a second parameter to our method. And what we're going to say is we're going to expect a second parameter, a to-do class. I call it to-do. And the .NET framework is intelligent enough to kind of, I wouldn't say guess, because that's not quite the right language to use, but it will try and look at the body of our request as it's a post request, and it will map it to whatever we put here. And in this case, we are mapping it to a to-do class, and it will attempt to do that. And it might fail. In this case, hopefully it won't, but it will try and map it to that. And assuming it maps through okay, then we should be good to go. So all I want to then do is attempt to put whatever we get here, assuming it gets mapped okay, I want to just pop it into our database. So the way we do that is we await on our context one more time into our to-dos collection, and we're going to add async. And what are we going to add? We're going to attempt to add what was ever passed in here. Now, we are doing absolutely no validation here at all. Even in our Node application, we did check to see whether name was there and all that kind of stuff. We're not doing any of that here. So definitely not production ready. And another interesting fact about the minimal APIs is it doesn't really come with a validation framework. If you chose not to do a minimal API, you actually get a lot of validation stuff with the other flavor of the .NET API. And I go into all that in my video on minimal APIs. Not to say you can't add validation to minimal APIs, you absolutely can. You can bring in other frameworks to do all that for you. I'm not going to do that. Again, path of least resistance. All right. The other thing we need to do is, just because we've added it, doesn't mean to say it's going to persist. We do need to do one more thing on our context. We need to save changes, async. And if you forget that step, it won't actually get saved into the database. And then all we're going to do is we're just going to return use results, and we're going to use the created method. And into our created method, we're just going to basically give a path to where the created resource can be found. So we'll say it can be found at API/to-dos. And the reason I'm using a $sign here is we're going to use something called string interpolation, which means you can use curly brackets with inside your double quotes and specify a variable. And so I'm just going to specify to-do ID of the object that's just been created. And then finally, you'll pass back the full model, which will get passed back as the body of our response. And that should be us good to go. So we'll save that off, do a .NET run. And I'll come back and explain this a little bit, just so we have a bit of context around it. But let's try and do this now. And it worked. So we get a body response back. This is basically this thing here being passed back. We get a 201 created result. That's because we've made use of the created method. And this bit here is basically the location of where we can find that resource should we need it in the future. And Insomnia does this sometimes. It does put these kind of tooltips up, which, there we go, disappears. If you look in the headers, the response headers, we do get this location here. Okay, so it's telling us where we can find it. It doesn't, interestingly, put in the full path. It doesn't put in the base URL. It just puts in the relative URL. You could add that in here, obviously, just chosen not to do that. All right, so basically what we've ended up with is we've ended up with 3 APIs, 2 endpoints each, all doing exactly the same thing. And I'm sure you will agree there are a lot of similarities. And there are a lot of differences. Which one you choose is entirely up to you. And again, bear in mind, in all three instances, we have literally just scratched the surface. But hopefully, in following this video, and thank you for doing that by the way, you've learned enough about each of the three frameworks to maybe make a decision in which one that you want to use going forward. So if you liked the video, give it a like. If you've not done so already, think about subscribing. And of course, don't forget the free cheat sheet and all the free training over on lesjackson.net. If you're interested in that, why don't you check that out? But until the next time, stay safe, and I'll see you again when I make my next video.